Scalars and vectors are fundamental concepts in mathematics and physics that describe quantities in different ways, based on their magnitude and direction. Let's explore each of these concepts. Scalar. A scalar is a quantity that is fully described by its magnitude, size, alone. Scalars are one-dimensional and do not have a direction associated with them. Examples. Mass. It tells you how much matter an object contains, and it is measured in units like kilograms, kg, or grams, g. Temperature. It indicates the hotness or coldness of a substance and is typically measured in degrees Celsius, degrees C, or Kelvin, K. Time. Time measurements, such as seconds, s, or hours, h, are scalars because they only have magnitude. Vector. A vector is a quantity that has both magnitude and direction. Vectors are represented graphically as arrows, where the length of the arrow corresponds to the magnitude, and the direction of the arrow represents the direction of the vector. Examples. Displacement. If you move from one point to another, the displacement vector not only tells you how far you moved, magnitude, but also in which direction you moved, direction. Velocity. Velocity is the rate of change of displacement with respect to time. It includes both speed, magnitude, and direction. Force. When you push or pull an object, the force exerted is a vector because it has both a magnitude, how hard you're pushing or pulling, and a direction, the direction in which you're applying the force. In mathematical notation, scalars are typically denoted by lowercase letters, example, m for mass, t for temperature, and vectors are denoted by boldface lowercase letters or with an arrow symbol above the letter, example or f. It's important to distinguish between scalars and vectors in various scientific and engineering fields because they behave differently in mathematical operations. For example, when you add or subtract vectors, you need to consider both their magnitudes and directions, whereas with scalars, you can perform arithmetic operations, addition, subtraction, multiplication, etc., without considering direction. In summary, scalars represent quantities with magnitude only, while vectors represent quantities with both magnitude and direction. These concepts are foundational in physics, engineering, and various mathematical disciplines. The dot product and cross product are two important mathematical operations that can be applied to vectors in three-dimensional space. These operations allow you to manipulate vectors and obtain useful information about their relationships and properties. Let's explore each of these operations. Dot product, scalar product. The dot product, also known as the scalar product or inner product, takes two vectors and produces a scalar, a single number, as its result. The formula for the dot product of two vectors and is given as equals asterisk asterisk cos theta, where is the dot product of vectors and are the magnitudes, lengths, of vectors and, respectively. Theta is the angle between vectors and. The dot product provides information about how much the two vectors align with each other. If the dot product is positive, it means the vectors are pointing in a similar direction. If it's negative, they are pointing in opposite directions, and if it's zero, they are orthogonal, perpendicular, to each other. Some common applications of the dot product include finding the angle between vectors, calculating work done by a force, and determining the projection of one vector onto another. Cross product, vector product. The cross product, also known as the vector product, takes two vectors and produces a new vector as its result. This new vector is perpendicular to the plane formed by the original two vectors. The formula for the cross product of two vectors and is given as times equals asterisk asterisk sin theta asterisk, where times is the cross product of vectors and are the magnitudes of vectors and, respectively. Theta is the angle between vectors and is a unit vector perpendicular to the plane formed by and. The direction of follows the right-hand rule, where you curl the fingers of your right hand from vector toward vector, and your thumb points in the direction of. The cross product provides information about the direction and magnitude of a vector that is perpendicular to both input vectors. It is often used in physics and engineering to calculate torque, angular momentum, and magnetic fields. In summary, the dot product produces a scalar and measures the alignment between two vectors, while the cross product produces a new vector perpendicular to the plane formed by the input vectors. Both operations are essential tools in vector algebra and have various applications in mathematics, physics, and engineering. The triple vector product is a mathematical operation involving three vectors that results in a new vector. There are two forms of the triple vector product: the scalar triple product and the vector triple product. Scalar triple product of vectors. The scalar triple product takes three vectors, typically denoted as n, and produces a scalar, a single number, as its result. The formula for the scalar triple product of three vectors, n, is given as times. This can also be written as times or times. The scalar triple product is used in physics to calculate volumes and determine whether three vectors are coplanar, lying in the same plane, or not. If the scalar triple product is 0, the vectors are coplanar. If it is non-zero, they are not coplanar. Vector triple product of vectors. The vector triple product takes three vectors, typically denoted as n, and produces a new vector as its result. Scalar vector triple product, scalar triple vector product. This form of the vector triple product involves a scalar triple product and is expressed as follows: times equals vector triple product, vector triple vector product. This form of the vector triple product is also known as the vector triple product proper and is expressed as follows: times equals. It helps describe how angular momentum changes when multiple forces act on an object. In summary, the triple vector product involves three vectors and can result in either a scalar triple product, or a vector triple product, depending on the specific operation. These mathematical tools are valuable in various physics and engineering contexts, particularly in situations involving angular motion and vector manipulations. Scalar fields and vector fields are concepts used in mathematics and physics to describe how values, either scalar or vector quantities, vary with position in a given space or domain. They are fundamental in fields like calculus, electromagnetism, fluid dynamics, and more. Scalar field: a scalar field associates a scalar value with every point in a given space or domain. In a scalar field, each point in space has a unique scalar value associated with it. Mathematically, a scalar field can be represented as a function that takes spatial coordinates as input and returns a scalar value. For example, in 2D space, a scalar field could be represented as phi, x, y. Example: temperature distribution in a room is a scalar field. At each point in the room, you have a unique temperature value without any direction. Vector field: a vector field associates a vector with every point in a given space or domain. A vector has both magnitude and direction and can represent quantities like velocity, force, electric field, or magnetic field. In a vector field, each point in space has a unique vector associated with it. For example, in 2D space, a vector field could be represented as x, y, equals vx, vi, whereas the vector field and vx, vi are the vector components at each point, x, y. Example: wind velocity in the atmosphere is a vector field. At each point in the atmosphere, you have a unique wind vector specifying both speed and direction. Scalar fields and vector fields are used extensively in various scientific and engineering disciplines. In physics, scalar fields often represent potential energy, temperature, or pressure, while vector fields describe forces, electric and magnetic fields, fluid velocity, and more. In mathematics, these fields are used in calculus to study the behavior of functions and solve problems involving multivariable functions. In engineering, scalar fields might describe quantities like temperature and heat transfer problems, while vector fields describe things like fluid flow or stress distribution in structural analysis. Analyzing and understanding how scalar and vector fields change in space is crucial for solving complex problems in science and engineering, as it helps in predicting and modeling physical phenomena.